Today we're going to take a look at a rational function graphing exploration. So our steps are going to be to graph each function on the graphing calculator and then answer the questions that follow. And my hint was make sure to put parentheses around your numerator and denominator. So you're going to go to your y equals menu. You might be on your emulator on the computer. So if you want to just follow along with me on the front page, then for the back page, you're going to use the emulator on your computer. So my function first is x plus 3. So I'm going to put x plus 3 in parentheses, divided by x minus 4, and I'm going to put that in parentheses. It's always nice to hit zoom 6 before you graph it, just because it gives you back your 10 by 10 viewing window. So here is my graph, and it's a little bit hard to tell where the asymptotes are. An asymptote is something that a graph is moving towards. So take your best guess. So my best guess is this vertical asymptote is at 4. See how 4 is directly in between these two curves? So when I'm sketching my graph, I'm just going to kind of put that in there because I know that they're approaching that line. It looks like my my y-intercept is somewhere in that area. So it's kind of going like this, and then it's coming up through the axis, right? So we're just sketching a graph. We're trying to figure out where things are happening. And the other part of the graph is kind of up here. So that's sketching a graph. Let's see if we can answer these questions. Where is this y-intercept? So the y-intercept, if you are tracing on the graph, let's see, if I hit trace, oh, it traced it right for me. So at 0, negative 3/4. And I think you can see from your equation, if you plug in 0 for x, don't you get negative 3/4 right in your equation? What about the x-intercept? So I don't know if tracing will get me exactly on the x-intercept or not. I'm pretty close. So at negative 3, it appears to be the x-intercept. So this was my x-intercept here. So at negative 3, 0. And if you notice, negative 3 is what you would plug in to get negative 3 plus 3 is 0 in the numerator. And isn't 0 divided by negative 7 just 0? So you can start seeing maybe from the equation what the real values are if it's hard for you to get them on the calculator. And we'd already talked about the vertical asymptote being at x equals 4. And there is a horizontal asymptote, so it's a little bit hard to see what the graph is approaching. So one strategy you can use, if I go to second table setup and I go to a high value for x, like 100, second table, it looks like the graph is approaching something right around 1. See how I'm closer and closer to 1? And if I go second table setup, if I go all the way out to 1,000 second table, now I'm getting even closer to 1, 1.007. So the asymptote is at y equals 1. So it looks like the graph is getting closer and closer to y equals 1. There's a reason for that we will learn later, but for now I just want you kind of making an observation from the graph. All right, so now I'm going to go on to the second graph. So y equals this time x divided by x plus 4. So here's my rational function this time. And it looks like it has an x-intercept and a y-intercept right at 0, 0. And if I look closely, 1, 2, 3, 4, it looks like my vertical asymptote's at negative 4. X equals negative 4. 1, 2, 3, 4. So if I have a vertical asymptote at negative 4, and my graph's kind of coming up like this, and then the other part of the graph's over here, my x-intercept and y-intercept are both at 0, 0, right? Because that's the same. And we said negative 4 for a vertical asymptote. It's kind of hard for me to tell what the graph is approaching here, but maybe it's at y equals 1. So there's a way to calculate that, and we'll learn that later. But for now, I just want you estimating. What does it look like when I go in my table out to 1,000? See how I'm at 0.999? So 0.999 is really close to 1. All right, graph number 3. So this time I've got x minus 4 over x plus 1. Check out what that graph looks like. See, they're starting to kind of look similar, right? They're just kind of that parent function shifted around, a couple different things. So let's see, my y-intercept is at negative 1, 2, 3, 4. 1, 2, 3, 4. So that's my y-intercept that I can see on my graph. And my x-intercept appears to be at 1, 2, 3, 4. So 4, comma 0. 1, 2, 3, 4. So you're just using the calculator to try to estimate the best you can. And then there's another part of the function over here. Can I tell where the asymptote is? Halfway in between looks about negative 1 to me. So there's an asymptote here. You know, we're not looking for exactly the right answer because you don't know how to find the exact right answer, but just making observations on this graph. You know, what does it look like your asymptotes are, right? So maybe again, I have an asymptote at 1, right? Because it appears to be approaching that from either direction. All right, and then the last one that I wanted to do together, and then you're going to look at the back page. The back page might not follow the same patterns that the front page did because the powers on the back page are higher. So just do your best, sketching the graphs, seeing if you can determine the x and y intercepts. So this one goes way far over. Let's see, it looks like its x-intercept is at negative 2. And halfway in between, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Makes sense, right? Because 6 minus 6 is 0. So it makes sense that this would be undefined at that point. Let's see, my y-intercept is somewhere between 0 and negative 1. If I plugged in 0 for x, I would get negative 1/3. So my y-intercept is actually at 0, comma, negative 1/3, negative 2, comma, 0. The vertical asymptote was at 6, we said, and goes like this, and then over here. So it's approaching again something, maybe y equals 1. See how it's shifted up over the x-axis because it cuts through right here. All right, so it's just an exploration. So there's no right or wrong answers down here. This is just a sketch of the graph. Use the calculator to try to answer those questions. You're going to try the back page now. So, you know, question 5, 6, 7, and 8, put them in your calculator. Sketch what the graph looks like. It doesn't have to be exact. See if you can think about the x and y intercepts and asymptotes. Maybe even look at the equation if you're not sure the exact answer, and see what you can come up with. And then you are going to submit the back page of this through Google Classroom. So you only need a picture of 5 through 8 to put on Google Classroom. Thanks.